Hello everyone. For today's lecture, we're going to start with chapter 5, which is linear equations. Linear equations. Before starting the chapter off, let me ask you, what are linear equations? Let's see an example of a very basic linear equation, which is basically the equation of a line y equals to mx plus c. একটু rearrange করে দেখি, y minus mx equals to c, right? এখানে আমার variables গুলা কোনটা কোনটা? My variables are that can vary basically, which are y and x, right? And m is basically the slope of the line and c is the constant. So these two are basically my constant terms, right? So they are not going to change. My variables are basically y and x. And second thing to notice is here, the powers of these variables are basically 1, right? So what we can say when designing a linear equation is that we can use multiple variables. It can be a set of x, y, z, u, or we can also set it like something like this: x1, x2, x3, x4, using this set of variables, or many more. All right. So these, if we can use multiple variables, but the condition here applied is that the powers of the variables, the powers won't be greater than 1. The power won't be greater than 1. If it is greater than 1, if any of the variables have a power greater than 1, then we cannot call it a linear equation. It's basically a non-linear equation. Okay. Let's move on. Let's say we have a system of linear equations. System of linear equations, which are, let's see the first equation, a11 multiplied with x1 plus a12 multiplied with x2 plus goes up till a1n multiplied with xn equal to b1. Let's see here, this was my first equation. Here a11, a12 and up till a1n are basically my coefficients of their respective variables. Here x1, x2 up till xn are my variables. I'm denoting them as my variables. And a11 up till a1n are basically my coefficients, which are so basically my constant terms. And equals to b1 is also a constant. This is also a constant. All right. Let's see the second equation, how we can write it in a system of linear equations. This will start with a21 multiplied with x1 plus a22 multiplied with x2 will go up till a2n multiplied with xn equal to b2. If we continue this, it will reach an1. This is the nth equation. an1 multiplied with x1 plus an2 multiplied with x2 will go up till ann multiplied with xn equal to bn. So this is basically the first equation. This is the second one. This is the nth equation. So we can collectively say this is a system of linear equations. So what we want to do here is basically solve this system of linear equations for these specific variables x1, x2 up till xn. Okay, and these coefficients a11 up till ann are basically my constants, whereas b1, b2 up till bn are also my constants. All right. So here in this system of linear equation, the xi's are my variables. Xi's are my variables where I belongs to the set 1, 2 will go up till n, right? Starts from 1, goes up till n. And the coefficients a we can represent them as Aij. Alright, where I is the row number and J is the column number. Where J is the column number. Alright, so I is my row number and J is my column number. So let's see, আমরা যদি second row এর second column এর নাম্বারটা দেখতে চাই তাহলে এটা কি হবে? A22 basically. So second row, second column, A22. Second row, nth column, A2n. Nth row, nth column, so it's basically ANN. Alright. And for representing the B's, we can just say it simply as BI's. Alright. Because এখানে column একটাই, so we don't need to express the columns explicitly, মানে আলাদা করে columns গুলো দেখানো লাগবে না. Just use the row number. Alright. B1, B2 up till Bn. Acha. So this was my system of linear equations. We can basically represent them in a matrix form, in their matrix form. Just simply write it as something like this: A multiplied with X equals to B, where A is an n into n matrix, X is an n into 1 matrix, and B is an n into 1 matrix. A hochilo basically consists of these coefficients A11, A12 up till AN1n. Abar hochilo will go up till ANN. And X matrix, the X matrix consists of these variables. It's n into 1 matrix though. So n number of rows and 1 column. So x1 থেকে নিয়ে x2 xn পর্যন্ত প্রত্যেকটা variable থাকবে. And the B is a n into 1 matrix. So B1 থেকে নিয়ে Bn. Let's see. Acha, এখানে A and B are basically constants, right? These are constants, right? So we can basically solve for X by taking A inverse multiplied with B. To dekhi, how would we solve this? So here, basically my matrix was A multiplied with X equal to B. Let's see the A matrix, which was A matrix starts with the first element A11, second element of the first row A12 will go up till the nth element A1n. Second row to start with A21, A22 will go up till A2n. If we continue up till nth row, AN1, AN2 will go up till ANN. And the X matrix looks something like this: x1, x2 will go up till xn, equal to the matrix B, the B matrix, which looks like B1, B2 will go up till Bn. Just basically think of it like this: যে আমরা হচ্ছিল first row টাকে A matrix এর first row টাকে যখন আমরা X matrix এর সাথে multiply করতেছি, the whole column resulting valueটা কি আসে? The B1, right? So আমরা first linear equation টা পেয়ে যাই না of my system of linear equations. This is basically how we separated them into matrix. You basically don't need this, but hopefully just a simple idea to know how it works. All right. So ultimately, we can say that we can solve this equation by saying A multiplied with X equals to B. So A here is a constant, B is here also a constant. So we can just say that X equals to A inverse multiplied with B. So A matrix টাকে যদি inverse করে, if we can multiply it with B, we can basically solve for all the individual variables of X. এখানে দেখেন আমার A inverse টা is basically an n into n matrix. One thing to notice is that A is basically an n into n matrix, so আমার A inverse টাও একটা n into n matrix ই হবে. And B here is a n into 1 matrix. So when we multiply them, the resulting matrix will also be a n into 1 matrix. The resulting matrix of a n into n matrix multiplication with an n into 1 matrix multiplication multiplied with n into 1 matrix is basically n into 1 matrix. Okay, moving on, we can say যে হলো a inverse calculate করতে পারলে we can multiply it with b and we can easily generate the individual values of all the variables x1 up till xn. But that is not always the case, because if a was, let's say for example, if a was a 2 into 2 matrix অথবা একটা 3 into 3 matrix, তাহলে আমরা easily a inverse টা calculate করে ফেলতে পারতাম. We can easily calculate a inverse, but here a is represented as a general matrix, so basically a n into n matrix. So what if it was 16 into 16? তখন আমাদের a inverse টা calculate করতে একটু problem face করব আমরা. So what we can do is basically use some tricks to modify my a matrix so that we can make easy calculations. ওটাই আমরা দেখব এখন in the form of lower and upper triangular matrices. So before we move on, we're basically going to need some properties from linear algebra. There are some properties that we're going to need, properties from linear algebra. The first thing, AT is the transpose matrix of A. Transpose matrix এর ব্যাপারে যদি আপনাদের idea না থাকে, then you can simply write it something like this. If A was said to be A, B, C, D, then we can say that the transpose matrix of A is basically A, B, and C, D. Just row gula will be replaced with columns. Then first row ta ki chilo A, B. So first column ta ki hobe A, B. Second row ta C, D. So second column ta hobe C, D. Basically A, I, J, if we transpose it, the resulting variable just row or column ta interchange হয়ে যাবে. Alright, so একটা ছোট example দিয়ে দিই আপনাদেরকে. If A was said to be something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, then the transpose of it would look like kori amra. First row ta 147, so first column ta hobe 147. For second row ta 258, so second row ta hobe second column ta hobe holo 258. Third row ta 369, so third column ta hobe holo 369. এইটার কথাই দেখি আমরা. এটার জন্য স্পেসিফিক্যালি যদি আপনারা রো নাম্বারটা দেখেন, which is 3 and the column number is 1, এখানে 3 এর কলাম নাম্বারটা কত? এখানে রো নাম্বারটা হয়ে যাচ্ছে 1 and কলাম নাম্বারটা হয়ে যাচ্ছে 3. সো 3 1 ছিল 1 3 হয়ে যাচ্ছে. সো I এবং J এর ভ্যালু ইন্টারচেঞ্জ হয়ে যাচ্ছে. আচ্ছা, এটা গেল ট্রান্সপোজ ম্যাট্রিক্স. সেকেন্ড থিং উইল নিড ইজ যে A we'll call A symmetric if A is basically equals to its transpose. So A matrix jodi looks exactly same like it's the transpose of it, we'll call it symmetric. Third property that we'll need is basically that A is we'll call A a non-singular matrix if the determinant of A is not equals to 0. Basically a solution exists for A inverse. Determinant 0 হয়ে গেলে তো আপনার A inverse এর জন্য কোনো solution পাবেন না, right? So basically a solution exists for A inverse. Alright, so there's some tricks that we can use to calculate A inverse. Okay, moving on. So rather than having to rely on the exact solution of A inverse, rely on the exact solution to A inverse, we're going to use something called lower triangular matrix or upper triangular matrix. So let's see the lower triangular matrix first. Lower triangular matrix. So let's say for the lower triangular matrix we are taking, let's say my n is equals to 4. মানে আমার হচ্ছিল 4টা রো থাকবে and 4টা column থাকবে for my A matrix. Alright. So it's basically a 4 into 4 matrix. Okay. So if n is equals to 4, I can say that my lower triangular matrix looks something like this. Lower triangular matrix. My lower triangular matrix looks something like this. First element take L11, second dash L1, L21, L22, third row complete correction L31, L32 up to L33, fourth row L41, L42, L43, L44. Baki gula 0. This is my lower triangular matrix. Multiplied with the X matrix, jeta chilo variable gula X4, so majkhane X3. Acha. Chart use kortechi. So, and the B matrix looks like B1, B2, B3, and B4. Alright. So, এটাকে আমরা lower triangular matrix বলতেছি because a diagonally চিন্তা করেন যে diagonaler নিচের হাফে আমরা we're getting the values. Upper halfটাতে diagonaler upper halfটাতে we're getting zeros, but নিচের halfটাতে we're getting values. So basically that's why it is called a lower triangular matrix. Alright. এই lower triangular matrixটা এই যে আমরা হচ্ছিল ফর্মুলাটা কি ছিল যে a multiplied with x equals to b. So এটাকে আমরা ফর্ম করতেছি saying যে এটাকে ট্রান্সফর্ম করতেছি l into x equals to b, right? So এই যে এখান থেকে এই ট্রান্সফরমেশনটা এটা আসবে হচ্ছিল using Gaussian elimination. আমরা হচ্ছিল next video lecture দেখবো how to perform Gaussian elimination so that we can make a lower triangular matrix or an upper triangular matrix. Alright. এই ফর্মেটে আনতে পারলে lower triangular matrix ফর্মেটে আনতে পারলে the calculation is basically very easy. Just L11 first rowটাকে first column এর সাথে multiply করলে we get B1, L11 into X1 equals to B1. It's because বাকি এই তিনটা 0 হয়ে যায়, এই X2, X3 আর X4 0 হয়ে যাচ্ছে. So first elementটা calculate করে ফেলতে পারবো. First variableটা is basically B1 divided by L11. এগুলো তো constant, right? এটাও constant. So basically we have the values for L11 থেকে start করে L44 and B1 থেকে start করে B4. So we can calculate for X1, X2 and X3 and X4. Alright. এটা কিলো. So we are getting the value of X1. Simply আবার হচ্ছিল second rowটাকে যদি multiply করি with the whole column and we'll get B2. So L21 into X1 plus L22 into X2 equals to B2. We have the value for L21, X1, L22. Just calculate করতে হবে for X2. We also have the value for B2. So X2টাকে এক সাইডে রেখে যদি আমরা হচ্ছিল পুরো ইকুয়েশনটাকে ওই সাইডে নিয়ে যাই, it will look like something like this. B2 minus L21 multiplied with X1 divided by L22. Alright. Same goes for the third row. L31 multiplied with X1 plus L32 multiplied with X2 plus L33 multiplied with X3 equals to P3. So we're going to solve for X3. We already have the value for X2 and X1. So basically these two are going to generate constant terms. So X3 is equals to P3 minus L31 into X1 minus L32 into X2 divided by L33. So basically it is called a top-down approach. It's basically called the top-down approach because আমরা start off করি হচ্ছিল X1 থেকে and we move up till X4 by solving each and every variable for the system of linear equation. Alright, that's why it is called the top-down approach. So we start from x1 and consequently solve up to x4. Alright, moving on. So we can basically see a pattern here of some kind. একটু check করে দেখেন, we can basically see a pattern here of some kind. যে আমার এখানে b1 আসে, x2 এর জন্য b2, x3 এর জন্য b3, and divided by their respective L11, L22, L33, right? And minus L21 multiplied with x1. এটার জন্য আসে হচ্ছিল 0, এটার জন্য হচ্ছিল minus L31 into x1 minus L32 into x2. যাচ্ছে হচ্ছিল 3 এর 8 পর্যন্ত, মানে 2 পর্যন্ত যাচ্ছে। সো আমরা যদি এটাকে হচ্ছিল একটু ইয়াতে লিখি, ম্যাথমেটিক্যাল নোটেশনে রিপ্রেজেন্ট করতে চাই, সো আমার each and every variable xj can be represented saying j it's bj minus the summation of ljk into xk, where k goes from 1 up to j minus 1. Alright, and divided by ljj. Here j is equals to 1, 2 and goes up till n. So প্রত্যেকটা individual variable আমরা calculate করতে পারি using this formula. So this is called forward substitution. One more thing to notice here is that we can calculate a solution for each and every variable if and only if L11 and L2 into 2, L33 and L44 is not equals to 0. If either of them is equals to 0, তাহলে আমাদের determinant of L টা আমরা 0 এসে পড়ে, because our determinant of L is basically L11 into L22 into L33 into L44. Alright, so এটা যদি either of them are 0, এটা পুরোটা 0 হয়ে যায়। বা আপনি যদি এখানেই চিন্তা করেন যে if either of মানে L44 এর কথাই চিন্তা করেন for calculating the fourth variable x4, so 4 এর জন্য যদি আমি L44 0 হয়ে যায়, এটা চলে যায় হচ্ছে ইনফিনিটিতে, so we can't basically calculate a solution for x4. Alright, so we have to keep in mind that L11, L22, L33 and L44 should not be equals to 0 so that we can calculate a solution. Similarly, we're going to see upper triangular matrix right now. We're going to see upper triangular matrix. The idea is almost similar to the lower triangular matrix. Upper triangular matrix. আইডিয়াটা অনেকটাই সিমিলার, জাস্ট আমরা হচ্ছে L কে U দিয়ে রিপ্লেস করে দেব, where U is equals to U11, U12, U13, U14, 0, U22, U23, U24, 0, 0, U33, U34, 0, 0, 0, U44. Alright, and U multiplied with x is equals to b. Alright, so once again upper triangular matrix, because it is a upper triangle form করতেছে, that's why we are calling it a upper triangular matrix. Alright, যে ডায়াগোনালের উপরে সব ভ্যালুস গুলো আমরা আনতেছি, and ডায়াগোনালের নিচের হাফটাতে we're basically making it zeros so that আমাদের সলিউশন করতে ইজিয়ার হয়ে যায়। ওয়ান্স अगेन এটাও আমরা হচ্ছিল ইউটা হচ্ছিল বানাবো ইউজিং Gaussian elimination, যেটা হচ্ছিল আমরা নেক্সট লেকচারে দেখব। সো এখানে হচ্ছিল যে ফর্মুলাটা আমরা হচ্ছিল ইন ডেপথ ক্যালকুলেশনে যাচ্ছে না, ওয়ের জাস্ট লিস্টিং ডাউন দ্য ফর্মুলা, যে xj এর জন্য বেসিক্যালি uj দিয়ে ডিভাইড হয় bj minus the summation of k goes from j plus 1 up till n multiplication of u jk multiplied with xk. alright, এটার summation where j goes from n up till 1. Start off হয় হচ্ছিল একদম নিচের এলিমেন্টটা থেকে. So we're basically যদি আমরা এটার কথা চিন্তা করি, we're starting off our calculating x4, then we move on to x3, then we move on to x2, then up till x1. So it's basically called a bottom-up approach. Bottom-up approach. So we are first calculating xn, then xn minus 1, then xn minus 2, it goes up till x2, then x1. Alright, so we're calling it a bottom-up approach, and this is basically backward substitution. So let's say আমরা তো upper triangular matrix ও দেখলাম, lower triangular matrix ও দেখলাম. এখন হচ্ছিল আমরা we want to figure out the complexity, the computational complexity to solve a lower or upper triangular matrix. We want to find out the computational complexity. What is it? It's basically the number of operations performed, right? So basically the number of operations performed. Let's see, আমাদের previous exampleটার কথাই চিন্তা করি যে j equals to যখন 1, lower triangular matrix এর জন্য চিন্তা করি. We're basically doing this for lower triangular matrix. যখন j is equals to 1, we are basically performing only one division, which was what? যে b1 থেকে নিয়ে হচ্ছিল L11 divide করি. That's it. যখন j is equals to 2, we are performing one division and one multiplication and one subtraction. Right? Just refer back to the calculation that we did for lower triangular matrix, and you can see that we are performing one division, one multiplication, and basically one subtraction. When j is equals to 3, we are performing one division, two multiplications, and two subtraction. You can just refer back to the calculations again, and you can see it there. Multiplication plus one subtraction. Right? আমি basically এই ফরম্যাটে লিখতেছি just so that it's easier for me to generate a pattern. Alright? যে j equals to যখন 4, একটা division plus 3 into 1 multiplication, 1 subtraction. So when j is equals to 4, we are performing 3 multiplications and 3 subtractions. So if we want to calculate the total number of operations, then it comes, we can say that it is summation of j starting from 1 goes up till n, 1 plus 2 into j minus 1. This is the 1. এই 1টা হচ্ছিল ডিভিশনের জন্য দিচ্ছি, আর এই 2টা দিচ্ছি হচ্ছিল একটা মাল্টিপ্লিকেশন এবং একটা সাবট্রাকশনের জন্য, আর একটা মাল্টিপ্লিকেশনের জন্য এই বেসিক্যালি 2টা আসতেছে. So basically যখন আমার j এর value is 1, when my j is equals to 1, we are performing how many operations? Only one operation, which was division. So a 1 minus 1 is equals to 0. So basically থাকতেছে হচ্ছিল 1. আর যখন j is equals to 2, we are performing 3 operations, which are একটা division, একটা multiplication, একটা subtraction. So 1 plus 2 into 2 minus 1. So এটা 1 হয়ে যায়, we basically end up with 3. Same goes for j is equals to 3 এর জন্য একটা division, দুইটা multiplication, দুইটা subtraction. So in total 5টা operation হয়. So j 3 minus 1 হচ্ছিল 2 দিবে, 2 into 2 4, 4 plus 1 5. So if we dilute this equation, আমরা যদি simply একটু হচ্ছিল dilute করে লিখি, হচ্ছিল একটু simplify করব জিনিসটাকে, then we can say যে n, summation of n, j starts from 1 goes up till n, 1 plus 2j minus 2. Just multiply করছে. Alright, so we can say that this is j equals to 1 থেকে start হয়, 2j minus 1. এটাকে হচ্ছে নেক্সট পেজে নিয়ে যাই. So total number of operations করতেছিলাম, total number of operations. So it was j is equals to 1 থেকে নিয়ে n পর্যন্ত 2j minus 1. Alright. So আমরা হচ্ছিল সামেশনটাকে আলাদা করে নিই। একটা আসবে হচ্ছিল 2 multiplied with যে 2টা বাইরে লিখতেছি আর কি বেসিক্যালি j equals to 1 থেকে স্টার্ট হয় j আর মাইনাস j equals to 1 থেকে স্টার্ট হবে goes up till n of 1. So এটা যদি simplify করি, it is basically n number of times the addition of 1. So n into 1 basically. So it just gives us n. আর এটা হচ্ছিল সিম্পল অ্যারিথমেটিক প্রগ্রেশন যে j equals to 1 থেকে নিয়ে n পর্যন্ত সামেশন যদি করি, it stands n plus 1 into n divided by what? 2. Right? This is the summation of this whole thing. A part just summation যদি আমি হচ্ছিল করতে চাই from 1 till n, this is the formula to calculate it. আর just সঙ্গে একটা 2 multiply হবে given যে হচ্ছিল আমাদের একটা বাইরে 2 আছিল। আচ্ছা, এটা যদি সিম্পলিফাই করতে চাই a2 আর a2 কাটা যায়, তো লাস্টে থাকে কি n square plus n minus n. So we are ending up with n square. So when we are solving a lower triangular matrix, when we are basically solving it for a lower triangular matrix, we have to perform n square number of operations. We have to perform n square number of operations just to solve a lower triangular matrix. যেখানে আমার lower triangular matrix আসে হচ্ছিল from Gaussian elimination, which we are going to see in the next video lecture. All right.